Right, folks. So welcome to 2.1 algorithms. So we're going to start on paper 2 content now. Um, so first things first, you need to know a couple of things about computational thinking. So computational thinking is essentially three key terminology that you just need to remember for the exam, really, and maybe apply it in the exam as well. So you might have to apply this. So you've got abstraction to start with. Abstraction is basically where you remove the unnecessary details, leaving you with the information that you want and that you need. So it could be that, for instance, a car, when you're drawing a car, you are only really looking for the information that you need or the necessary details that you need, such as four wheels, maybe a door, a chassis. What you don't tend to do is you don't tend to have the engine there, you don't tend to have the window wipers, all of those sort of details that you don't really need to know for it to be known to be a car. Decomposition is where you split that bigger problem down into much smaller, more manageable chunks. So that could be, for instance, a program that you're trying to do, which is like snakes and ladders. You break that down into who goes first, so rolling the dice and getting the person to whoever's got the most. You've then got the being able to play, but inside the play bit, you've got the fact that you could first of all roll the die. Once you've rolled the die, you can then actually move and take your turn. And then once you've had your turn, you do your snake or a ladder if you land on it. How do you win? There's so many different things, but by putting those into much smaller chunks, you can then dedicate a developer to each of those. So you could say, well, actually, you go off and program the bit where we roll the die. You now go off and do if you win or not, if you do a snake and ladder, all of those different ones, each person can do individually. Algorithmic thinking is basically being able to think like a computer and solve problems without use of a computer. So when we do our coding by writing it down on a piece of paper, that is essentially it. Then you need to know a bit about algorithms, and we're going to concentrate more on the next video than the 2.2 video, Programming Fundamentals, about what an algorithm is, how to actually build an algorithm for different scenarios, and we'll probably do that over a couple of parts, really. But an algorithm is basically a set of instructions that solve a problem. So it will essentially give us some instructions, maybe like cleaning your teeth in the morning. First of all, you get your toothbrush out the cupboard, put it under the water, put in your toothbrush, brush to the left, brush to the right, whatever you do. Okay, so algorithm, just a set of instructions that solve your problem. An input is just something that the user enters into a program to allow us to do something. It could be a mouse click, it could be a keyboard entry, it could be a microphone in terms of sound, anything along those lines. And your output is something that your computer shares with your user. So it could be sound, it could be vibration, it could be visual display like a monitor, anything along those lines. In the exam, they might ask you what inputs, what outputs might be in a particular scenario. Then you've got trace tables, and I know quite a few people find trace tables quite tricky because you're having to go through and look at a program that you haven't really done and you haven't done it yourself and you haven't made it yourself. So what I thought we'd do is just go through an example one. Now, it's really, really important when you do the trace tables, always read the question and keep reading it. Don't get ahead of yourself. Okay, I keep saying it in class, don't get ahead of yourself. Okay, now the exam board have started doing this where you put your line number in. That's something that I've not seen for a long while in terms of what the line number is going to be, but that I think will help you in the long run go through. So let's run through this. So we've got the pseudocode on the left hand side. Pseudocode is just code. Don't worry about what it is, what it isn't. It's just basically that. So we've got start equals 3 on line 1. So we've got line 1. So start equals 3. So we're going to do start to equal 3. Then we've got line 2. Well, line 2 doesn't do anything, so I'm going to leave that out. If you wanted to put it in, you could, absolutely. Line 3, we print start. So I'm going to go to line 3, and we're going to print start. Well, start is 3, so I'm going to output 3. Then I'm going to do line 4, so start equals start minus 1, so I'm going to do line 4. And I'm going to do start equals start, so start is 3, minus 1 is therefore 2. Then line number 5, until start equals minus 1. Well, again, my line 5 doesn't do anything, so I could write that down, but I'm not going to. But does start equal minus 1? No, 2 does not equal minus 1. So I'm going to go back to the beginning of the do, so line 2. Again, I'm not going to write that down, but you could if you wanted to. Then I'm going to go back to line 3, and line 3 says print start. So start is 2, so I'm going to output 2. Again, I'm not getting ahead of myself, I'm going right, nice and slowly. I would probably in an exam actually point to it, which I am doing on my screen, or keep like a pencil or another pen just on what line I'm looking at and what I'm going through. Now I've got line 4 again, so start equals start minus 1, so let me write line 4 in. And I'm going to do start equals start minus 1, so start is 2, just looking at above, so that becomes 1. Then my line 5, again, not going to write that down. Still start equals minus 1. Does the start, so 1 equal minus 1? Absolutely not. So we go back to the beginning, we do a do. Line 3, so let's go back to line 3. Print the start, so let's print the start, which is value 1. And then we do line 4, which is 1 minus 1, which is 0. Line 5, so until start equals minus 1, does 0 equal minus 1? Absolutely not. So let's go back to line 3. Line 3 is print start, so let's print start out, which is 0 at this point. Then we do line 4, and line 4 is print start equals start minus 1, so 0 minus 1, so that's going to be minus 1. Now that's the bit where we want to stop at because of until start equals minus 1. Well, now we've got start to be equal to minus 1. So now we can print out the line 6, so line 6 here, and we finish with finished, which is hard to write on a mouse. So that is your trace table, and that would get you 3 marks in your exam. 3 marks, nice and easy, I believe, for it to be done. Like I said, the exam board has started doing this line number, and I really like that because I think that will help you in the long run to go through it quite nicely. So yeah. So we've got also flowcharts. Now, one thing that I will say is there are 2 sections in your paper, section A and section B. In section B, you must write in code, so like in Python. They call it something called exam reference language, or OCR reference language. You can, in section A, answer at anything that you want. So you can do it in structured English, you can do it in flowcharts, but you can do it in coding. What that's really good for is there's always one programming question before section B, so in section A. And it's normally about 5 or 6 marks. If you do nothing else and you don't have a clue how to do it in coding, write it in English. Write it in structured English. Don't write down the question, don't read the question out, but do it in structured English and you'll get marks for it. Okay, you can do it in a flowchart. So if you're really, really struggling with that section A question, do it in structured English or do it in a flowchart. So in terms of, I'll show you what that means in a minute. On the next slide, I've got an example. In terms of flowcharts though, you need to know kind of 5 or 6 different shapes. So in an exam, the likelihood is they're not going to actually get you to make a whole flowchart, but they will make you do a bit of a smaller flowchart or fill in the gap sort of thing. So you've got start and end, which is a rounded oval. You've got arrows obviously pointing in the right direction. Input and output is a parallelogram. Process is a rectangle, and a decision, so like an if or is it, and that needs to have a yes or a no coming off it. So like here is yes, that way is no, and that is a decision in a diamond. Okay, the other one that you need to know is something like that, which is a subroutine. So that is very much like your when you want to call a function of any form, that will give you the subroutine there along the way. So you kind of really just need to know and remember those flowchart symbols, because when you get to do a flowchart, you get a mark for actually doing the correct shapes. So just remember those and get a bit of a practice on those. So this is what I was talking about. So this is section A, and it's a question that is asking you for an algorithm. And it asks you for an algorithm to ask the user to input the quantity of numbers they want to enter and read this value as an input. Repeatedly take a number as an input until the quantity of numbers the user's input has been entered. So the previous bullet point, while that is going on. Calculate and output the total of these numbers and calculate and output the average of these numbers. Now, quite a lot of you, I think, would be able to do that in Python and will be able to do that straight away, so you can do that. If you're really struggling and you can't remember some of the code, do it in structured English. Write it down what you want to happen, okay? So again, this isn't a question from part of the exam questions, but it's a good activity to do. So try and write that in Python first. If you're really struggling, do it in a flowchart if you really want to, and you can do it in structured English as well. So the answer is just here. So you need to have inputted and stored the value for the numbers that they enter. So if you just wrote input the quantity of numbers and store in a variable, you will get a mark for that. You will get a mark for that. Attempting to repeat, you get a mark for. So not even actually repeating, but attempting to. Correctly repeating the number of times given, so from that input previously. Correctly taking the number as input within the loop and calculate the total of these numbers. And correctly calculate an average for them. Okay, so you could just write that in structured English and you would get the marks for it. Now we're going to look at programming in a lot more detail in 2.2, and you've also got that programming booklet and all those videos that I'll link to that as well on this YouTube. So not going to go fully into the detail of that question there, but if you're really stuck, give us a shout. So then you've got your searching algorithms. And you need to know two types of searching algorithms. You've got linear search and you've got binary search. Linear search does not need to be in any kind of order, and all you do is you do it linearly. So you keep looking until you find the item, or you end up at the end of the list, and you start at the very end, start at the very beginning even, and work your way to the very end. So if we was trying to find 8, we'd look at 5 first. And we would say, well, does 5 equal 8? Nope. Move on to 12. Does 12 equal 8? Nope. Does 17 equal 8? Nope. Does 3 equal 8? Nope. Does 8 equal 8? Yes, we've found it. If we're looking for 34, we do the whole thing again. So we start at 5 all the way down, all the way through to 7, and then we get to the end and we go, it's not in the list. Okay, so it can be quite quick if it's at the very start of the list. We would never know that. However, it can be very slow for a large data set. So we've got then binary search. Binary search does have a bit of a stipulation, and that means that we do have to have the data that we are working with in order. So we have to have our data like we have here. So we've got 1, 3, 5, 7, 9, 11, 13, and 15. Works a lot quicker on data sets that are large, but it can be quite inefficient on the smaller data sets. So we start in the middle. We find if it is less than or greater than what we're trying to find, and then we remove either the ones that are greater on the ones that are smaller, including the one that we're looking at. So if we start and if we try and find 1 in the below list, first of all we try and find the middle. So we've got 8 items here. So the middle would be 4.5. Well, we can't find 4.5 there. So what we do is we go for the left-hand side of it. So this bit here would be the middle. So we go to the left, which is 7. Okay. Now 1 is less than 7, so we know, because it's in order, everything above here is irrelevant. Okay, so what we do is we get rid of it. And now, including the 7 as well, because we know 7 doesn't equal 1. Now what we do is we do exactly the same thing on the data set that we've got now. So we're left with 3, and we find the middle, and our middle is 3 in this scenario. And then what we do is we go exactly the same thing. 1 is less than 3, so we don't need anything above it, so we get rid of it. And now we're left with just the value of 1. So what we do is we find the middle of that, which is 1, and we do 1 equals 1, and we say we found the value. So it's a lot quicker, a lot fewer steps. However, in linear search, you would have found 1 very quickly if it was at the start of the list. Then we've got sorting algorithms, and you need to know a bit about sorting algorithms. You need to know 3 of them in total. You need to know bubble sort to start with. And what you do in bubble sort is we compare the 2 values that are next to each other, and we swap if we need to. Now, in an exam, I would swap all the way down to the end. So I would swap all the values, but it's entirely up to you how you want to work it out. The exam board will give you set sort of squares. You don't have to always fill them in. If you are filling all of them in very quickly, then you're probably doing it wrong. So what we do is this scenario here. So we compare 3 and 2. And 3 and 2 would then become swapped. So we get them 2 and 3. And we write down all of the other values that we've got. So we've written down 6, 20, 14, and 12. Okay, so that's by swap that we're doing it. Well, we look at 6 and 20. Well, 6 and 20 actually means nothing to us. So 6 and 20 mean that we don't have to swap. So we look at 20 and 14 this time, we do have to swap. So 20 and 14 we swap over. And again, we write all the other values around them. Then we look at 20 and 12. Well, yeah, we're going to have to swap those. So we swap those around as well, and we write everything else down. So that is by swap that we've been writing them down. In an exam, you can do it however you want. You could have just written it down as 2, 3, 6, 14, 12, and 20, because that would be all of one, all the way through one pass. And then we go back to the beginning. So we go back to look at 2 and 3. Well, 2 and 3 we don't need to swap. 3 and 6 are fine. 6 and 14 are good. 14 and 12, well, we need to swap those 2. So let's swap those 2 around, and we write everything in again. Now, one top tip that I would have for the exam is always write it out again. Write it out twice when it's sorted, because the exam board like it. And it just means that you might get an extra mark for redoing it at the end. So always write it out twice on a bubble sort. Then you've got an insertion sort. Now I think insertion sort is probably the easier out of the 3 even. So what you've got here is you've got 5 values here. You start with a sorted list, which is 5. In an exam, I would highlight them, or I would put a line around them of some form just to prove that it is that sorted and the others aren't. You've then got an unsorted list on the right hand side, and we've got a sorted list on the left hand side. I think that was a question in the exam this year. We then get number 12, and we insert number 12 into the correct place in our sorted list. So it goes next to our 5. So now we've got 5 and 12 sorted. We again look at 17. 17 is placed into the correct place, so therefore it is next to the 12. So we've got 5, 12 and 17 now sorted. You can see that I've highlighted them quite clearly. Now we've got 3, so we insert 3 into our sorted list. So 3 would go to the left of 5. And then we've got 8 to finish it off, so that would be going between the 5 and the 12. So we shuffle everything around and we've now got our sorted list. And that is all insertion sort is. Now we've got merge sort. Now merge sort, you will typically now get a question which has already got to the bit where they split them up into individual lists. Okay, so it's really important you read the question because you'll save yourself some time, or you'll gain yourself some marks if you need to. So here we've got 8 items. You might have a 9th. If you get a 9th, just leave it on its own. Leave it on its own all the way down and then merge it in at the very end. I've seen it done. Split it up into 2 quarters, 2 halves, and that would be into 2 fours. That's what I wanted to say. I've not done anything else with them, just split them up. Split those 4s into 2s and split those 2s into 1s. This is the step that I've said that some exam questions have started at. So they've said we've already split it all up for you into individual lists. You now need to do the process to sort them out. Okay, so you might not have to do all of those steps, but it's good to remember them. Now we're at this point, what we can do is we can merge those together. So we can look at 5 and 12. Well, 5 and 12 merge 5 and 12 together. Well, it become 5 and 12. Oh, they've all come up at once. 17 and 3, well, we'd swap those two around, so 3 and 17. 8 and 23 are already sorted. 25 and 7, we just have to swap them around. We then look at the pairs, and we merge them together. So 3, 5, 12 and 17. 7, 8, 23 and 25. And then you merge that last 4 together to make your 8, and that would be a sorted list. So you've got 3, 5, 7, 8, 12, 17, 23 and 25. So they are your steps, and that is how you really explain how you get one all the way through. So they're all your merge sorts. They're all your sorts and searches. Remember and apply them is essentially it. So some exam questions for you to have a go at. And like we did in paper 1, then what we'll do is I'll give you the question, you can pause me, and then I'll show you the answer. So here you're looking at abstraction being simplifying the problem. Only using necessary detail is absolutely fine for that one. Decomposition is breaking a problem down into smaller chunks. Brilliant, easily marked. And algorithmic thinking is a set of the steps needed to solve a problem. So this is the question that I was talking about earlier with the merge sort. So it's already saying that the first step is to divide the list into individual lists of 1 number each. This has already been done for you. It's really important you read that part of the question. So now we've got them into individual lists. Try and work it out now. So if you've merged it into a size of 2, so you've got 12 and 45, minus 99 and 100, minus 13, 0, minus 27 and 17, you get a mark. Then merge those into a 4, and you've sorted them, so minus 99, 12, 45 and 100, minus 27, minus 13, 0 and 17. And then when you merge those into your sorted list, that's where you get your 3rd mark. Have a go at binary search. So you get a mark for saying that you've got a middle value, or you're finding the midpoint. Compare this to house, and it doesn't work, so there's no match. because a pumpkin is greater than the house. So you get 3 marks for saying midpoint is pumpkin, compare that to house, and it's greater than house. That's 3 marks. You also get a 4th mark for getting rid of the top half of the list. 4 marks of a 4-mark question you can all do quite easily, and then repeat that process to get 6 marks, but you only get 4. Have we go at that one? So again, you get a mark for accessing Rob. You get a mark for does not equal Anna, access Anna, does equal Anna, so you stop and you find it. And then there's the 4 marks for that one. This one's insertion sort. So an insertion sort, I would just write it down in that little box at the bottom like you've got there. But you can write it in a list if you wanted to, like they've done on your at the top. So you've got Anna inserted before Rob as first 2 elements, Hugh correctly inserted, Emma correctly inserted, Patrice, and then Iqbal. So if you just wrote them down like that at the bottom, the guidance bit, don't know where my mouse is, otherwise I'd show you. Can't see it. There it is. So if you marked it like this at the bottom, if you did it like the bottom bit, you can get all the marks.